All right, to sketch a direction field for this equation, the first thing you want to do is build a table and fill it up with some ordered pairs. So we're going to have a table with our x, y pairs in it. And then we're going to have the second part of the table be our y prime, or our slope calculation. So of course, you should always try to use the origin if it's defined. So if we use the point 0, 0, and substitute that ordered pair, we get a y prime equal to 0. That means that we actually have a horizontal tangent line at the origin. You'll also notice that if I pick the point 1, 1, and I substitute into the differential equation, that slope is 0 as well. So at the point 1, 1, I have a horizontal tangent line. And I could continue to do this any place where the x-coordinate and the y-coordinate are the same. So at 2, 2, I can do this, 3, 3, 4, 4, 5, 5, and so on. Same thing is true for negative 1, negative 1, negative 2, negative 2, negative 3, negative 3, and negative 4, negative 4, and negative 5, negative 5. We can now pick some other points as well. For example, we can pick the point 1, 0 on the x-axis. And if we pick the point 1, 0, we're going to get a point or a slope of actually 1, because 1 minus 0 is 1. So at that point, we have a slope of 1. You will notice that if I pick the point 2, 0, I'm going to get a slope of 2, which is steeper. And I'm going to get steeper and steeper as I go to the right. Going backwards, if I use the point negative 1, 0, then that slope is going to be negative 1. So back here, it's going down. And if I continue that pattern, it's going to be negative and steeper as I move my way to the left. And now let's pick another ordered pair. Let's pick the point, say, 0, 1. If I substitute that in, that's 0 minus 1, so that's a negative 1 slope. So at this point, I've got a negative 1 slope. And then if I pick the point 0, 2, that's a negative 2 slope. And you notice that these slopes get steeper and steeper as I travel up the axis. If I try the point 0, negative 1, then that slope is a 1, and I actually have a positive 1 slope. And so in this direction, I'm getting steeper and steeper with a positive value for the slope. So now if I draw graphs, you will notice, if I put this all together, that I'm going to see trajectories, or solutions, if you will, that are going to be tangent to these. So they're going to come down and be tangent, and then go in this direction here. A little wiggly there, and then another one coming down, tangent, and going up, and so on. And so you get to see this general flow pattern here, where you see your solutions coming down and then going up to the right. Very important to keep in mind, again, that these are tangent, so they should be just intersecting the arrow at one place. So to be totally correct on that last one, I need to make sure I come down tangently and touch right at one spot, and then bend away very sharply in this direction. And the solutions don't cross, so that's probably a poor exaggeration there, so let me fix that. You just kind of draw this way, and this one will come along this one very closely. But again, these solutions are never going to cross. They're just going to be kind of running and flowing together in the same general direction, hence called, again, a direction field. So give it a try, and again, this is a tedious process, but if you draw a very slow, accurate picture, it's also rewarding. And you can always check your work using that D-Field program that I linked in the notes.